Hi, so today we are going to be working on a Platonic solids video, and we are going to be answering the question of why there are only 5 Platonic solids. So to start out, I am going to just give a few rules that we figured out in class. So in class we figured out that in order to make a Platonic solid, we need the shape needs to have at least 3 polygons around a vertex just to make the shape, right? So we know that we need at least 3 of them, because otherwise if it was any less than 3 it wouldn't be able to fully make the shape. 2, there is a gap. So we need a gap at each vertex, because without it we would not be able to fold it correctly, right? So if there wasn't just like a little space in between each of the regular polygons, then we wouldn't be able to fold it correctly and it wouldn't make the right shape. So we know that. So today we I forgot the third rule. And then the third kind of rule is that when we work with polygons, especially with the Platonic solids, we are going to be working with by their interior. We are going to be working by the interior, what their interior angles are. So we use the equation n, which is the number of sides, minus 2 times 180, divided by the number of sides again, to get the interior angle measure. And we know, kind of as just like a rule of thumb, that as soon as any of the angles goes above 360, it doesn't work anymore, because that's a first full circle. So then if it was greater than 360, it'd be going around. So the interior angles have to be less than 3, and we'll talk more about that as we actually do an example. So these are kind of our 3 rules. So we're gonna focus on triangles to start out with. So triangles, we know, are 3-sided. So if we're doing the equation, we do 3 minus 2 times 180 degrees divided by 3, and that is 60 degrees. So we know that each interior angle is 60 degrees. So we start out with 3 triangles around the vertex, because we know that that's the only way to make it a shape. So if we have 3 triangles with each interior angle of 360 degrees, we know that the 3 triangles, their total number of, or the interior angle of those 3 would be 180 degrees. Okay, so we know that 3 triangles works. So now we'll try it with 4. So when we do 4, we know it's basically doing 60 times 4, because now we have 4 triangles with interior angles of 60 degrees, and that's 240. Now we do the same thing, 5, which is 300, and 6, which is 360 degrees. So we know that we could do, in order to make this this Platonic solid with triangles, we could have anywhere from 3 to 6, right? Because we can go up to 360. However, what we know about 360 is that fits perfectly together, so there would be no gap, like we talked about as our second rule. So we actually wouldn't want to use 6 triangles around the vertex, because it wouldn't be able to fold properly. So we know with triangles we can have either 3 regular triangles, 4 regular triangles, or 5 regular triangles to make a Platonic solid. So that's 3 of our Platonic solids. Okay, so now we're going to move on to squares. So we know that squares have 4 sides. So we're going to do our equation. Remember, the number of sides minus 2 times 180 divided by the number of sides. So that would be 4 minus 2 times 180 divided by 4, and that's 90 degrees. So each interior angle of the square is 90 degrees, okay? So we know, again, we have to start with 3 in order to make the proper shape. So 3 triangles times, or 3 squares, times 90 degrees is 270. So that's the interior angle of all those. Okay, so we know that for sure 3 works. And now if we do 4 times 90, it's 360. So technically, yes, it would work. It wouldn't fold correctly, so we don't count 4, because there's not going to be a gap. So we know that with squares, only having 3 squares around a vertex is going to make a Platonic solid, okay? So now we want to keep going up until we're not able to prove it anymore, right? So now our next step is polygons. So with polygons, we have 5 sides, okay? So we're going to do that equation again. So we do 5 minus 2 times 180 divided by 5. And we know that each interior angle in a polygon is 108 degrees. So, like always, we start with 3 polygons, and 3 times or 108, sorry, of the interior angles times 3 is 324 degrees. So we know that that would still work. So we for sure would have 3 polygons around the vertex. But now, if we look, we do 4 times 108 degrees, and that's 432 degrees. That is way bigger than 360 degrees. So we know that 4 would not work, okay? So we know that 3 polygons are going to work around the vertex to make a Platonic solid. Now we'll keep going up, okay? So hexagon, there's 6 sides. So 6 minus 2 times 180, divided by 6. That should be, is 180 degrees is the interior angles of a hexagon. So if we do 3 times, because we have to start with 3 again, 3 times 180, that's 540. So that automatically is bigger than 360. So the smallest number of hexagons you can have around a vertex is even too big. So we know that we cannot even use 3. So actually, hexagons do not work to be a Platonic solid. And we know that if a hexagon doesn't work, then any number bigger than a hexagon isn't going to work, because they're all of the interior angles, and the other angles together are going to be too big. So we know that triangles, 3, 4, 5 triangles around a vertex works. Squares, having just 3 squares around a vertex works to make a Platonic solid. And polygons, having 3 polygons around a Platonic solid works, or around a vertex works to make a Platonic solid. And that's how we know what the 5 Platonic solids are and why we can only have those 5. Thank you.